Okay, 1.3. Okay. What do we do in 1.3? Is basically just mapping. Yeah, it's basically just combine everything we did. So I'm gonna speed through everything because it's already 9 o'clock. Okay. Let's review everything real quick. Y equals AF B x minus H plus K. This is our general formula. Alright. A is the vertical stretch or reflect over x-axis. So if A is negative, that means reflection. B, horizontal stretch, or I'll just reflect over y-axis. So for B, if B is negative, it's also means there's a reflection. Oh, sorry. That means there's also reflection. And for B, we do mapping. It's going to be 1 over B. H, left or right. If H is smaller than 0, like in the equation, for example, like x minus 3. H equals negative 3. Smaller than 0, that means it's going right. If x is bigger than 0, left. So for for H, it's always like reciprocal. I'm sorry. Reciprocal. Yeah, so like in the equation, if it's x minus something, it's going right. If it's x plus something, it's going left. K. K is up or down. K is bigger than 0. If it's positive, it's going up. K is smaller than 0. Whoopsies. Sorry. K is smaller than 0. Going down. Q. And then the mapping formula. 1 over B x plus or minus H AY plus or minus K. For the formula, if you understood all of these, this will be really simple for you. Cute. Let's look at examples. Example 1. Given that 3, 5 is a point on the function y equals f of x. Firstly, state the mapping process after each transformations and then find the new point. A. For A, y equals 3 f of x minus 2. So we figure out 3a equals 2, 3. That means vertical stretch by a factor of 3. And then k equals negative 2. That means go down by 2 units. So our mapping is x, because nothing affects the x value, 3y minus 2. And then you just plug in 3, 5 into all of these. Alright, so let's look at the second one. A equals negative 1 over 3. Negative, there's a reflection over the x-axis. Mapping. Wait, no, that's the b value because it's closer to x. I'm sorry. B, negative, reflection over y-axis. And there's horizontal stretch by negative 3. Yeah. So, see right here, by negative 3, left 2 units. So you plug in 1 over b, 1 over 1 over 3, which is just negative 3. 1 over negative 1 over 3, just negative 3. X minus 2 and y. Plug it in, find any points. I think you copied these notes, or you didn't. Okay. For this one, A is negative 2. So reflect over x-axis and a vertical stretch by a factor of 2. B is 3. So it's horizontal stretch by 1 over 3. K is negative 5, so it's go down by 5 units. So the mapping is this. and just plug in the points. Plug in 3, 5. This one. Plus 3, move it to this side, negative 3. Negative, a is negative 1, reflect over x-axis. H is negative 6, so if it's negative, that means it's gonna go right by 6 units. And then k is minus 3, so it's go down 3 units. The mapping is gonna be blah, 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 blah. For this one, remember, there's a common factor. You can take it out. So our b is going to be 3, blah, 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 blah. Mapping, plugging 35 into here. Oh my gosh. And the last one. Same thing, there's a common factor, 1 over 2. Plug it out, b, and then h value. Write down like horizontal stretch, write by how many units, and then you plug in the mapping and get the new points. So these are basically the thing. I'm gonna stop here real quick for like a couple seconds so we can take a screenshot. But yeah, these are all the things we need to know for transformations. Cute. Examples. Given the following function, y equals f of x. Well, see, we found a, b, c, d points, a, b, c, d points. We put down the points, and then you determine, oh, it's right here. I'm sorry. This is our transform equation. So let's see, I wrote all of them down. A is negative 3. A, B, H, K. Negative, reflect over x-axis, vertical stretch by a factor of 3. 1 over 2 over 2, 1 over 2 over 3, which is 3 over 2. So horizontal stretch, this is the b value. H, negative 1, right by 1 unit, and k is positive 1, so it's up by 1 unit. Mapping, b and h affects the x value. B, x, plus or minus, well right here, h is negative 1, so it goes right, so it's plus 1. Plus 1, negative 3, a value, y, plus k, which is 1. And then you just plug in the points you got from the original graph, and then you just like plug in the mapping we did, and then you'll get the new points. So I remember you asked like about the a prime, b prime. It's basically just a way to show like the new transformed like points. Yeah. This one, did we do this one? Yes, we did. Cute. Okay. The graph of the function y equals g of x represents a transformation. Wait, we didn't do this one, did we? We didn't do this one. But it's basically the same thing as this one. Like you just like label down the mapping. So for these type of questions, the first thing you do is label down a, b, h, k, each value, what like each symbol or like each variable, what do they like equals to, and then you also label down the number, and also what do they affect, like vertical shift, vertical stretch, vertical compression, or horizontal compression, or left or right by how many units, up and down by how many units. That's the first step. Second step, you do mapping. All right, if you couldn't do mapping, like if you couldn't figure out mapping, you just do each like transformations. For example, the first one, A, vertical reflect, reflect over x-axis. So you just reflect the entire original graph by the x-axis. So it's gonna go this way. Yeah, you just go do it step by step. And then after you get the mapping, you plug in the original points, and then you get the new points. And you get the new points, you just draw the graph. That's the steps how you should do a transformation graphing problem. Yeah, we didn't do this one. If you have questions, I'll explain to you tomorrow in class. Example 4. If y equals f of x equals root x plus 3, write the new equation for y equals 0.5f. 2x minus 5 plus 2. So firstly, what we did there, firstly, we expanded this part of the graph. This part of the equation. I'm just rewrite it. 2x minus 5. You multiply it, which is f 2x minus 10. Like that. And then what the frequency do we do? Oh yeah. So right here, see, you can treat this I'm using another color pen. You can treat this entire thing as x. It's the same thing as you did in the graphing, like the one I was talking about earlier, about like for example, f of x equals to something, like equals to square root of x, and then you just plug it into another question, like the one I was talking about earlier. I hope you get it, like the screenshots I asked you to send it to me, those ones. So you treat the brackets, entire thing, as f of x, and then you see right here, f of x equals root x plus 3. So you plug in, how can I write it? It's more simple and easy, straightforward to understand. Okay, let's rewrite this step. So we treat 2x minus 10 as x. All right. So you plug in this, see, x and x, you plug them in. So it's going to be square root of 2x minus 10 plus 3 is outside of the square root, you keep it outside. It's going to be like this. That's how we got into this step. And then we plug this part, everything, back into the original equation. So y equals 0.5 f 2x minus 5 plus 2. Do I have another red pen by any chances? No, yes, no, may. Okay, I'm gonna just use this one. Okay. Okay, see, we did expanded this this part, right? Like that's all we did here. We expanded and then we simplified it. So we just plug this back into here. So it's gonna be y equals to 0.5 f. There's no f. This is basically, I feel like I need to explain to you this question again because I feel like I'm doing a really bad job. Okay, I'm sorry, brain is glitching now. Okay, question, if y equals f of x equals root x plus 3, write the new equation for y equals 0.5 f 2x minus 5 plus 2. Here we go. Okay, so first up we did expand the brackets. Well, if you look at it, this is simplest way, like the simplest thing we can do. 2x minus 5, well you include the f too. Alright, so it's gonna turn to f 2x minus 10. And then you treat the brackets, inside of the brackets, the entire thing as x. So I'll say treat 2x minus 10 as x. Whoopsies. Okay. And then you plug in the x into here. So I'll say y equals f of x equals root x plus 3. So you plug the x in, so it's gonna equals 2 f of x equals f square root 2x minus 10 plus 3. Cute. Okay, and then we plug the entire thing, Jesus Christ, back into the original equation. Y equals 0.5f 2x minus 5 plus 2. So remember this entire thing. So like all of these steps is we simplified and expanded f 2x minus 10. Okay? So yeah, this is basically f 2x minus 5. You know, plug everything back in. 0.5. You can just ignore the f. There's nothing to do at this point. Square root 2x minus 10 plus 3 plus 2. And then you put 0.5 into here and into here. Expand the brackets. 0.5 times 2x minus 10 plus 0.5 times 3 is 1.5 plus 2. This times this equals to 0.5 square root of, actually we can't simplify it, I'm sorry, there's x. 0.5 square root of 2x minus 10 plus 1.5 plus 2 is plus 3.5. So this is our final answer. That's the simplest thing we can reach in this question. Amazing. But just in case you want to take a screenshot. Amazing. Next. Yeah, we're on 1.4 already. Jeez.